Right, here we're going to be at part of our series of how to improve. Then on based question practice for calculation. So I will go through this question to start off with, but not this question. Look at the need to be able to do this. And the first topic, an exponential. You need to understand what an exponential curve is. So here you'll see I have a graph y equals a to the x. Notice that no matter if I change my value of a using when a is very big, we can see closer to the axis top, closer to the x-axis down here on the bottom. And then as I get closer and closer, the line getting flatter and flatter and flatter. And as I hit 1, we see it turns into a straight line. Then if I go less than 1, flips around to the other side. Quite tricky to get this graph because actually as soon as I go below 0, the graph doesn't exist. There's no, it's impossible to draw a negative number to the power of x. Flipping. So between values that don't exist. So got this graph between 1, hit 1, graph is a straight line through. And no matter what value of a, here is all 1. Value a, you'll find it's still, even if I get value, it's still going to cross 1. So exponential graph, just a to the x, always cross. Now what we're going to do is, so therefore, I'm just going to now look at what happens if we multiply that graph. So let's a value, if I can get it. So let's just look at k equal to 1 on the green graph. Exactly the same red graph. There's a red graph. But now I'm going to show you the difference between these as we change the value of k. So as we increase k, we notice that the place where it crosses the y-axis also changes. Now if k is 3.6, look where it crosses the y-axis. It crosses the y-axis also at 3.6. If k is 5. It will now cross the y-axis at k. So if you times a to the x by a number, then that number is where it will. That's what you need to know. You need to know all about those changes. Let's just get a back over here. So even when it's positive, again, this one crosses at 1, and this one crosses at 5.1. Right, now I'm going to just move on. Looking down here. I'm going to just miss this one out because we're basically looking at non-calculator. Let's look at things where you might be able to do calculator paper. This going to look at knowing the shapes of your graphs. So here are some graphs. You need to know the shape of your graph. I'm just going to give you 1 minute to see if you can work out which graphs matches with which equation. This equation, in case you can't see small on your screen, is y equals sine x. This one is y equals x squared plus 4x. This one is equal to y equals 2 to the x. This one is y equals 4 over x. I'm going to give you minutes to have a look at those. See how you get along. Go through them. Right, here we go. So we're going to look at these questions, which matches. Now, you should know that a sine curve, okay, is going to be of this shape, and you need to know that it starts at the origin. So therefore, C is our graph for this one. It was y equals x squared plus 4x. Not any of those. I must have actually got that wrong. None that actually matches squared plus 4x because you factorize that. You get x plus x cubed. Sorry, x cubed plus 4. So if you, and you'd know that it would cross at 0 and you'd know it would cross at -4. So and none of these graphs do anything like that. There's a cubic. Which ones could be a cubic? One that I see could be a possible cubic. That one. Okay, cubics generally follow that shape or they follow this shape. So therefore, only one that's possibly a cubic. F. 2 to the x. Remember, we've got a choice of this one or this one. This one is when the value a to the x, when a is less than 1, that one. This is the value when a is greater than 1, so therefore that must be the one. The x. 1 over x, 4 over x. Now it's either going to have this shape. This shape will not happen. It will happen when we've got a minus sign, and we don't have a minus sign. This shape. So there's b. This one's going to be b for 4. Where get negative values. Now I've just noticed my stream has quite a low output. I'm just going to try and change it up a bit. While I'm doing that, I'll have a look at it. See if you can get the correct equation for these graphs. Zoom in a little bit, make it read them out. One is definitely x cubed, y equals x squared plus 4, y equals 1 over x, y equals 2 to the x. Right, here we go. Let's have a look at these ones. Sorry about the delay. I've hopefully got a better connection. Looks to be better. So we've got y equals x cubed, y equals x squared, y equals 1 over x, and y equals 2 to the x. So which one is not going to be the right one? So x cubes, remember cubics either go like this or like this. So this one looks like a cubic, and we haven't got any other cubics, so that is b. So that is going to be b is going to be y equals cubed. Now a, remember quadratics have a U shape, so that looks like a quadratic, and it's been shifted up by 4 in this case, so it could be y equals x squared. 4. And this one is an exponential. Okay, this one's exponential. We've been looking at exponentials. So this one is 2 to the x. The only one we don't have is 1 over x. That would look like that. Okay, let's just look at some on to the next stage of this section and look at equations of circles. I'll just give you 10 seconds to try and see if you can work out, not 10 seconds, a little bit more than 10 seconds to work out what the first one was. Okay, and then I'll Alright, that should have been enough time to be able to get to this circle. Now, this is a circle with centre 0, 0, and it's got radius equal to 2. And you know that the radius is equal to 2 because the radius is the square root of this number here. So we're going to draw a sketch of a circle, radius minus 2, going to cross 2. Okay, and so that's what that one is. Remember, that gives you the square of the radius. So to find the radius, we square root that. So I'm not going to make you do 4 or all exactly the same. Check this to this one here. I'm going to give you 2 seconds to have a go. 2 seconds to have a go at that one. Okay, it's actually been enough time to do this one. So we know that it's going to be a circle, centre of the origin, radius equal to 5. Or when you do it, make sure, if you don't give you axes, make sure you use a ruler. Draw this, and it's 5, 5, minus 5, and 5. Okay, let's go on to the next section, being able to help us solve this problem. We're going to look at transformations of curves. And the transformations you need to know are these ones here. You need to know that if you add a value to the whole function, then that will translate you up by a vector 0a. And if you add the value inside the function, notice inside the brackets here, then it will translate it the opposite direction. Translate it minus a in the x direction. And then if you've got a minus f of x, that reflects in the x-axis, and f of minus x reflects in the y-axis. Now notice this minus x here is inside the brackets, and x plus a is inside the brackets as well. Anything that's inside the brackets means you get movement that way. And then anything outside the brackets means you get movement that way. This is an easy way to help you remember. So those are the transformations you know. So let's have a look at graphs with some transformation. Here we go. Here's a graph transformation. And you've got to draw, this is f of x. Try and draw f of x plus 1 plus 5. Just try and draw that one. 2 seconds to try and see. That's one. Right, here we go. So, all you need to realise is it's going to move to the left 1 and it's going to move up 5. Remember, it's opposite of that is minus a. If it's x minus a, you move to the right a. fx plus a, and you move to the left. You're going to go a to left. What we're going to do is we're going to draw this. It's going to go to the left 1, point peak here will go left 1, and it's going to go up 5. 1, 5. This point left 1. Well, actually, let's get this left 1 and then up. Those 2 points end up here. Right, I'm just going to too important that it just, and when you do it, you won't have again, when you do it, you won't have a grid. Say where that point is going to be -1. This point here will be, what's there? 3. This point 1 comma. Okay, so that's what happens at transformations. Anyway, I'm not going to spend too much time with that. I want to get on to the non-calculator paper I've done for you. And let's have a look at the problem that caused the issue. Done enough. Have a look at that. So I'm going to give you just 3 minutes to work your way through this problem and see if you. Right, sorry. let's have a look at this question. So we know that a graph of y equals a to the x always cross at 1. So the coordinates of that point 1. Equation of the circle x squared plus y squared equals 16 will normally be a circle radius. Now if we translate it with vector 3 naught, that means we're going to go 3 that way. So this point 7 and this point 1. So we need to draw a sketch of that. So that axis roughly the place. There's minus 7 axis. And we need to label the coordinates the center B, so it's going to be at 3. So that's what we do. We need to label the center B, which we've done, 3, 0. We need to put the points where it crosses the axis, minus 1 and 7. Right, what I'm going to do now is just give a 5-minute break, and then we'll go through questions which are based on last year's non-calculator paper, which I've taken other similar questions on the similar topics to give you some non-calculator practice. Hopefully, just give you a brush up ready for tomorrow. Come back in about 5 minutes.